In this lesson, we're going to talk about energy efficiency, which in some respects is an unsung hero. I want to start out by acknowledging that while in a previous lesson I talked about how customers as a whole want electricity that's available to them 24/7 and at an affordable price, not all customers want the same things. In fact, there are a number of indicators that can predict what we tend to prioritize when it comes to electricity. For instance, for a business, electricity is an operational expense that directly impacts their bottom lines. In households, there can be very different priorities based on income, age, and even political affiliation. So while one size does not fit all in an industry that has an obligation to serve all, energy efficiency is one of those rare things that can fit most. Before we jump in with both feet, I want to help you understand the difference between demand and consumption, two very important concepts. Electric companies plan how much power they need by looking at peak demand. Peak demand is when the most power is being used. Let me give you an analogy. If you look at your car, your speedometer tells you how fast the car can go. While your speedometer might say your car can go over 100, mine says it can go 180, for a maximum speed, you likely won't do that. Or at least I hope not, because then you'd be a real ticket magnet. Anyway, just because you regularly, hopefully, don't go that fast, there might be a time when you need that extra speed. For example, to pass a truck on a highway to avoid an accident. Another car-related example is the parking lot in your local mall. Most of the time, all of the spaces are not taken up. But over the holidays, what happens? More people shopping, more cars, more spaces filled up. The mall developer built the parking lot for peak demand, which is holiday shopping. While I'm using the car as an example, I'll also tell you about consumption. Consumption's like your car's odometer, the mileage tracker. It tells you how far you've gone. Now, this isn't a perfect example, of course, but hopefully it helps you understand the difference between peak demand, which means you can use your air conditioning, refrigerator, charge your iPad, and do the laundry all at the same time while not sitting in the dark unless you choose to, and consumption, which is how much you use. While the previous examples used miles per hour and miles, and even how full a parking lot is as measurement, electricity consumption is measured based on kilowatt hours, and demand is measured in kilowatts. Now that we understand energy use, energy efficiency is a pretty simple concept. It means reducing electricity use. This appeals to a broad range of customers because it offers environmental benefits, as well as the plus of being easier on our wallets, right? We use less electricity, it impacts the environment less, and then we spend less money. This isn't likely a surprise to anyone watching this. What might surprise you is the fact that electric utilities actually do things to help their customers reduce electricity use. I know when I first joined the industry, it surprised me. Coming from a highly competitive telecommunications industry, I distinctly remember sitting in a meeting, having to practically sit on my hand to prevent myself from asking, excuse me, but why would an industry want to sell less of its own product? That made absolutely no sense to me. I mean, think about it. When have you ever seen an ad coming out of a beverage company that says, hey, you might want to slow down, you're drinking way too much soda? Not going to happen.
Some people question, why are you in the business of pushing conservation and energy efficiency programs when really you're in the business of selling electricity? And it's a really good question. We've been in the energy efficiency business since 2008, and our customers have saved more than 1 billion kilowatt hours from programs specifically designed by our utility. There's a few different things, a few different ways that we think this is important. One, we know affordability is an issue for many of our customers. We know that it's critical to help them save on their energy bills, and these programs can help them do that in many ways. We also have to build for peak demand periods. So we're putting assets into the ground, power plants that don't run all the time, that just deliver energy during peak time periods, and that's an expensive way to deliver energy. So some of our programs specifically address trying to shave that peak so we can at least delay putting power plants and additional infrastructure in the ground, and that's important to us.
Well, electric utilities have been encouraging their customers to use less energy for decades. And it's not just talk, they walk the walk. They offer customers financial incentives like low-cost loans, appliance and equipment rebates, and even energy-efficient products like light bulbs and shower heads. These initiatives are known within the industry as demand-side management. Let me give you an example. If you've ever taken advantage of a rebate your utility provides you to purchase a new furnace, dishwasher, or other energy-efficient appliance, you are benefiting from a demand-side management program. For business, we're talking some pretty big projects potentially, including lighting retrofits, building automation upgrades, and HVAC system improvements. A utility will typically help identify the opportunities by conducting a pretty comprehensive energy audit using one of their energy experts who typically has an engineering background. By installing the devices, equipment, or appliances, you're reducing how much electricity you're using from that point forward, at least when it comes to those particular devices. I had the chance to talk to Howard Geller, Executive Director of the Southwest Energy Efficiency Project, which is a public interest organization that promotes energy efficiency.
Energy efficiency is using less energy to power our lights, power our appliances, power our vehicles, get the energy services that we desire using less energy.
Now that you know how they do this, let's get back to the question of why they do this. As you now know, most utilities are highly regulated by state and local jurisdictions, and they receive a government incentive to encourage these programs.
Utilities are actually helping their customers save energy and buy less electricity or less natural gas. Utilities across the United States have these programs. They're often called demand-side management programs or energy efficiency programs. And the utility is doing this to reduce energy waste, to help their customers lower their utility bills by saving energy, and just improving the customer satisfaction among their customers. Saving energy is less costly than supplying energy from a new coal-fired power plant or gas-fired power plant or wind turbine or a group of wind turbines that we call a wind farm, or solar power, solar PV, photovoltaic power. Usually costs 2 to 4 cents per kilowatt hour to save electricity through more efficient lights and appliances and so forth, while all these other forms of electricity supply cost 6-7 cents or more per kilowatt hour.
Regulators have done this to encourage reduced environmental impact, especially recently, but also to help avoid the cost and the time needed to build new power plants in response to increased usage. Electric utilities also have programs that encourage their customers to use less energy during very specific times. They will target high energy usage or peak times. These programs are a little different than what I just talked about because they focus on having the consumers using less energy during a pretty specific time frame. That is when the usage is highest or at its peak.
Demand-side management programs are something that we've had in the municipal utility space since the beginning. Obviously, early on, it was seen most notably with our industrial customers, where it was in the utilities' advantage to ensure that we could move demand around to sort of meet our system's availability and our system's capacities. But we're seeing it more and more move down over the last 6 or 7 years, even into the residential space.
The idea is to try to reduce at peak. So one of the programs that work really well is for residential customers is the cycling of air conditioning. The company gives you a rebate, and then they put a device on your air conditioner to cycle that the air conditioner to keep everybody's house cool, but they don't have all the air conditioners come on at the same time. And they're trying to reduce their demand, and the company wants them to reduce their demand at peak as well. But that's more towards motor controls, more efficient motors, more efficient lighting, more efficient equipment that the commercial customers are using. So they're more based on equipment and lighting, where residential is more intended for peak air conditioning load.
In the industry, these are called demand response. Some people consider it a subset of demand-side management. Let me give you an example. Picture it being a record-breaking hot summer day with scorching temperatures. It's a Monday. Businesses and homes all have their AC blaring. Manufacturers are producing goods and products. Offices and businesses downtown are trying to keep cool. Well, now picture an unlikely but possible event. Boom, just like that, a generation unit goes down, and this causes a supply shortage. Now what happens? Well, let's just say that if utilities didn't have a really comprehensive demand response plan in place, like they do, this could get ugly really fast. Let me give you an example of demand response in action. There's a hotel in your area and it has over 600 guest rooms, some great meeting space, and a really nice restaurant. As you can imagine, they use a lot of electricity. They would work with the utility to figure out what could get turned off if a situation like I described arose. So it could be things like turning off some non-essential lighting, or maybe like turning off the ice machines. The hotel could also do things like postpone running their dishwashing and laundry operations because they're pretty extensive. For you and I as homeowners, let me use a different example. Of course, we would have a much smaller impact individually, but there are more residential customers than business customers, and this can really add up. A lot of utilities will pay you to install a device that can turn on and off your central air conditioner. This is called cycling, and many people don't even notice it's happening, except, of course, because the utility lets them know.
Really, the most cost-effective thing you can do to improve energy use is to actually not have to generate the energy itself because you're not demanding it. That's the first thing you'll want to do. And then you move on to the renewables and the other types of clean energy. So demand-side management is a very important part of overall energy and electricity systems.
Demand-side management definitely does not get the kind of attention it probably deserves, which is kind of a shame because it's so important for our system.
So it's actually, the utilities are often incentivized, or it's actually good for them to reduce that peak power. They want to have, they would love it if power was generated, demand was the same across day and night, but that's not the way it works. So demand-side management is important to them so that they can be using the most cost-effective power and not have to use the peaking power that's the most expensive for them. So it's really a dialogue and a relationship between the consumer, the customer, the utility, and the public utility and the regulators.
These energy efficiency programs, over time can really, add up to significant energy savings. Electricity use would be 10% higher if it hadn't been for the utilities efficiency programs. And that 10% savings translates to about $1 billion of economic benefits for customers.
Case in point, NREL has a lab that focuses on testing consumer-oriented, efficient products. I had the opportunity to tour this facility and I learned a lot.
We have a laboratory that we are actually have equipment such as washers, dryers, microwaves, even electric cars, things that you would have in a home. And we use that equipment to better understand how the demand operates, so we can have them all start up at once, we can operate them at different times, and we can look at the way smart meters integrate with that to be able to manage the demand related to those particular equipment. So that facility looks like, I won't say it looks like a home, it looks like a bunch of equipment all stacked up together, but it's highly instrumented, and then it's linked up to a model or a system that simulates the way it would integrate with the grid.
Regardless of whether they work at an energy efficiency public interest organization, at a utility, or at an innovation-focused national lab, the experts agree that getting more efficient in our own use is a step not to be overlooked.
Energy efficiency is a lot less visible and glamorous than rooftop solar or a wind farm. It's a lot of small measures and hidden measures. More efficient light bulbs, a more efficient water heater in the basement, more efficient compressor in your refrigerator. You tend not to see it. It's not so visible, and so it just isn't as often as sexy as putting a solar system on your roof. You're not going to impress your neighbors with a more efficient water heater or furnace, but it's very practical. It's very cost effective. The energy efficient water heater or furnace will pay back a lot faster than the solar panels on your roof.
To sum it up, energy efficiency, while it's been around for a long time, holds even more importance as customers seek advancements in environmental protection. While renewable energy gets a lot of the press, energy efficiency programs will continue to evolve, especially with smart technology, and will become even more important.